In this video, we're going to take a look at operations with functions, such as addition, subtraction, multiplication, and division. So we can add and subtract and multiply and divide functions much like we can with actual numbers. So for instance, the sum of two functions, which is denoted f plus g of x, means you just take the two functions and add them together, f of x plus g of x. In other words, we take their corresponding outputs or their corresponding y values and we add them together. Same thing with subtraction. We can subtract two functions and come up with a difference. Here we have f minus g of x, which is just f of x minus g of x. Or in terms of coordinates and outputs, subtracting your corresponding y coordinates. We can multiply as well, f times g of x, usually just written with the functions together without anything separating them. So f times g of x is f of x times g of x, where you're multiplying the corresponding y coordinates. And finally, we have division, the quotient here, f over g of x is f of x over g of x, with, again, the stipulation that g of x cannot equal 0 because we'd have the 0 in the denominator, and that's not allowed, not even for me. So in terms of y coordinates, we're dividing our y coordinates when we're dividing our functions. All right, so we're going to look at f of x is 6x squared minus 2x, and g of x is 3 minus 1 over x. First, let's simplify f plus g of x. So let's just take these two functions, f and g, and we're going to add them together and combine like terms if we have them. But here, 6x squared minus 2x plus 3 minus 1 over x, there aren't any like terms to combine, so we're done with example 1a. Example 1b, evaluate f plus g of negative 1, and I've copied down f of x and g of x here in the heading. So one approach here is f plus g of negative 1 is f of negative 1 plus g of negative 1. And when we look at f of negative 1, we get an 8. And when we look at g of negative 1, we get 4. And then 8 plus 4 gives us 12. Now that's one option we have. Another option we have is, since we already figured out what f plus g of x is, we can just plug that negative 1 into f plus g of x. So 6 times negative 1 squared plus 2 times negative 1 plus 3 minus 1 over negative 1, and that also gives us the same answer of 12. So either one of these two methods we can use to evaluate the sum, in this case, of a function at x equals negative 1. Part C, f minus g of x. We're going to take f of x, the 6x squared minus 2x, and subtract the entire 3 minus 1 over x. So remember, when subtracting an entire expression, we have to distribute this negative to all the terms. So the negative, multiply it by 3, and multiply the negative and the negative 1 over x. We get negative 3 and plus 1 over x. And there's nothing to combine with anything in f of x, so we're done with example 1c. Part D, g minus f of x. So we're switching the order here, which is going to be g of x minus f of x, and that's 3 minus 1 over x, and now we're subtracting the 6x squared minus 2x. So put that expression in parentheses and distribute your negative, and you get 3 minus 1 over x minus 6x squared plus 2x, which just so happens to be the opposite of what we had in example 1c. So if you just took each of these answers and made them their opposite, made them negative, you would get your answer for D. Part E, f times g of x is f of x times g of x. So 6x squared minus 2x times 3 minus 1 over x. 6x squared times 3 is 18x squared. 6x squared times negative 1 over x. The x in the denominator is going to cancel one of those x's out. We'll get minus 6x. And now when we distribute the negative 2x through, negative 2x times 3 is negative 6x. Negative 2x times negative 1 over x is plus 2. And we got negative 6x and negative 6x. We can combine those together to make negative 12x. So our final answer for f times g of x is 18x squared minus 12x plus 2. All right, finally part f, f over g of x, which is f of x over g of x, is going to give us 6x squared minus 2x over 3 minus 1 over x. And we have a complex fraction here, so we're going to get rid of the tiny fraction denominator by multiplying the entire numerator and the entire denominator by this little tiny denominator of x. So that'll clear out our tiny fraction of 1 over x here. When we multiply through, we're going to multiply 6x squared minus 2x by x. We'll get 6x cubed minus 2x squared. And then 3 minus 1 over x times x gives us 3x minus 1. Now, in the numerator, 6x cubed minus 2x squared, we have a greatest common factor of 2x squared. So if we factor out the 2x squared as the greatest common factor of the numerator, we get 2x squared times 3x minus 1 all over 3x minus 1. And the 3x minus 1 in the denominator is going to cancel out or divide out the 3x minus 1 in the numerator, leaving us with just the 2x squared. All right, that about does it for this video. Thanks for watching, and I'll see you next time.